I'm Anil Kumar. Welcome to my series on linear systems. In this video, we have taken up 5 questions. All these questions will be solved using the method of substitution. Now, these questions have been picked up from previous test papers, so they should really help you in understanding the topic and also getting good marks. You can always pause the video, copy these questions, try them out. Right, so I think you can see clearly questions 1 to 3. Now you can also copy the questions 4 and 5, right? So last question is kind of a thinking question where we are trying to solve a system which involves equations 1 over x plus 3 over y equals to 3 over 4 and 1 over x plus 2 over y equals to 5 over 4. Now these equations are not linear equations. However, we'll use the strategies which you have learned in solving linear systems to solve a nonlinear system also. So that will be of great importance. The very first question also involves a few definitions of consistent, dependent, and independent terms, which creates confusions to many students. So let's begin from here and see how to solve linear systems using the method of substitution. Well, the very first question is a communication question which says, provide an example for each of the following systems: consistent and dependent, consistent and independent, inconsistent and independent, right? So that is the kind of question. Now here you need to understand the term consistent and inconsistent, right? So we use the term consistent when we have a solution. Right? Now, whenever we're talking about a linear system, we could have one solution or we could have infinite solutions, right? So let's look into this word consistent first, right? So we have two different cases. A system is consistent if we have a solution. Now, when is it dependent and when is it independent, right? Now, a system will be dependent if we have two lines and both the lines are one over the other. So in this case, we have infinite solutions, right? So in this case, this is actually dependent. The second line is dependent on the first, right? So it is dependent. And it has infinite solutions. Clear? The other case is a standard case where we have any two lines, right? So it is independent, any two lines which are not parallel. So non-parallel lines will always intersect at one point, right? So wherever they intersect, right? So that is independent. So this is independent. So it has only one solution. Now, whenever we're talking about a linear system and we say solution, we are talking about, so let me write down here. Whenever we say solution, we mean point of intersection. Clear? So that's what we mean, right? Now the question was, provide an example for each of the following. So in this particular case, I could give you an example which could be, there are two lines, so we say y equals to 2x plus 1, correct? So let's say we have this line y equals to 2x plus 1. We could also write the second line as 2 times this, for example. So we have, and I'll write it in standard form. So I can write this as 4x and 2 times y. I'm bringing it here, minus 2y, right? Plus 2 equals to 0. So this particular system is overlapping lines. They're exactly same lines. They have the same y-intercept at 1, right? As shown here, positive slope of 2, and that becomes the equation. Is that clear to you, right? Now in the second case, if we are trying to write an example for consistent and independent, that means we have two lines which are not parallel. So we could say y equals to, let's say, x plus 1, and the other line could be y equals to, let's say, minus half x minus 1, correct? So that will be an example for independent and consistent. Is that clear to you, right? Now the third case here is when we have inconsistent independent, right? So now normally we do not use the term independent, we just say inconsistent. That means we have two parallel lines, right? So in this case, we are talking about two lines which are parallel. So if we have parallel lines, in that case, there won't be any point of intersection, right? So let's say these are the two lines, right? So they are, let's say they are parallel lines. So that is the case where we have no point of intersection. So they do not intersect. So these are parallel lines. Example in this case could be, let's write down in a different ink. So we could say y equals to, but their slope is same, right? We say x plus 1 and y equals to x plus 2, for example. Different y-intercepts, right, make them parallel. If the y-intercepts are same with the same slope, they become collinear, right? So they are aligned. Is that okay? So that is what it is. So the system becomes dependent, consistent if they are overlapping, but if they are parallel, then it is inconsistent and independent, right? There could be many lines like this. So I hope that makes sense. Now let's move on and take up questions where we are going to solve a system using the method of substitution, right? So when we say, the question here is to solve system by substitution and check each solution, correct? So we need to check our solution also once we solve. Substitution really means we have to substitute one value into the other. So we have two equations here. Let's call them equation 1 and 2. So we'll substitute value of y from 2 in 1, right? So this value of y, which is 2x plus 7, I am going to substitute in 1. That is the whole idea, right? So I hope you got the concept. So I could rewrite this as 2x plus 7 equals to x plus 1. Is that clear? So I've done the substitution, and therefore this method is called substitution method. Now bring the x's together. So we have 2x minus x equals to 1 minus 7. So that is x is equals to minus 6. Once we get the value of x, find y. So let's call this as our equation 3. Now we'll sub from 3 in 1, right? So we get the value of y as equal to, which is x plus 1. Now we're substituting minus 6 here for x plus 1. So we get the value minus 5. And therefore, we get our point, which is x is minus 6 and y is minus 5. Is that clear to you? Correct? So that is our step to find the solution. Now, let us see how to check the solution. So let's check the solution. To check, we have to substitute this point in our equation. So let's put 2x plus 7, use second equation. So x is minus 6. So if I do 2 times minus 6 plus 7, what do I get? 2 times minus 6 is minus 12. Minus 12 plus 7 is indeed minus 5. So that matches with the y value, correct? So it is perfectly fine, right? If I use the first equation, in that case, we have minus 6 for the x value. So minus 6 plus 1 is equal to minus 5. So that verifies that the first equation is also satisfied. So I hope that is clear, right? Okay, so that is how you should be solving these questions. Let's take the second question now. So this time, let's say this is equation number 1, this is equation number 2. We'll sub equation 1 in 2. Y equals to x plus 1, I'm writing here for y, right? So we get 2x plus, instead of y, I'm writing x plus 1 equals to minus 14. So that is 3x equals to minus 14 minus 1, taking 1 on this side. So we have 3x equals to minus 15, x is equals to minus 15 over 3. That gives us a value of minus 5. To get the value of y, we'll substitute this in x. So we know y is equals to x plus 1. Substituting minus 5, we get minus 5 plus 1, which is minus 4. So we get our value of y as minus 4. So the solution here is the x value being minus 5, y value being minus 4. You can now always check the result by substituting these values, correct? So let's do it for the first question. For rest, I will leave it to you, okay? So we have two different equations to check. So we'll sub the value of x and see. Do we get the same value for y? So if I do minus 5 plus 1, I do get minus 4, which is the correct value of y, correct? And if I do in the second equation, if I write 2 times minus 5 plus minus 4, what do I get? I get minus 10 minus 4, which is minus 14. That also works for us, right? So which is the right side. Is it okay? So we have checked that the left side is equals to right side in both the cases. And therefore, it works for us, correct? Let's move on and take the other examples. I'd like you to pause the video, solve these questions, and then look into my suggestions now. So we have another set of questions here, part C and D. So here we have 2x minus y equals to 1, x plus 3 equals to y. So basically we are given y equals to x plus 3, right? So that gives you the y value. So the equations are, let's label them as 1 and 2. So we'll substitute y value from 2 in 1, correct? So we get 2x minus y is x plus 3. Put them in brackets. Sometimes if you don't use brackets here, you might make a mistake, right? So what I've done here, this value I've substituted here with minus, within brackets I've substituted the value, correct? Open the bracket. So you get 2x minus x minus 3 equals to 1, which is x equals to 1 plus 3, which is 4, right? Now you could substitute this value of 4 in your equation to find y. So y is equals to x plus 3. So we get x is 4, 4 plus 3, which is 7. And therefore, the answer or the solution is 4, 7, correct? Now, I'm not doing the check. I'm leaving the check part to you. Please check. Okay, let's do the next question. Now, in this case, again, we are given y as 1 minus 4x. Let's substitute, right? So that is our first equation. This is our second equation. So we'll substitute a value of y from 2 in 1, correct? So we get 2x minus 1 minus 4x equals to minus 5. So we get 2x minus 1 plus 4x equals to minus 5. So we get 2x plus 4x equals to minus 5 plus 1, which is 6x equals to minus 4. X equals to minus 4 over 6, which is minus 2 over 3, correct? To get the value of y, we'll substitute minus 2 over 3. So we get 1 minus 4 times 2 over 3, correct? You can write like this. That is, say 1 minus 8 over 3, right? Taking 3 as a common denominator, you could write this as 3 minus 8, and so we get the value of y as minus 5 over 3. And therefore, the solution is minus 2 over 3, comma, minus 5 over 3. So it's a good point to always write your solution as a coordinate point, right? So as shown here. Clear? Now, question number 2, part E and F. So we have to follow the same procedure. These are all practice questions for you. So this is our, again, equation number 1. This is equation number 2. We'll sub 2 in 1, which is y equals to 2x minus 5 here. So we get 3x minus 2x minus 5 equals to 6, or we have 3x minus 2x plus 5 equals to 6. 3x minus 2x is x, and we have 6 minus 5, which is 1. So x is 1. So that is our equation 3. We'll substitute 3 in 2 to get the value of y. So we get y equals to 2 times 1 minus 5, which is equal to, okay, let's write here, 2 minus 5, which is minus 3. So the answer here is, solution or answer is one and the same thing, 1 minus 3. You could substitute and check, so please check. Clear? Let's do part F. So here we are not given explicitly the value of y. So, but you can isolate. So from our first equation, we could actually write y equals to 2 minus 2x, right? Or minus 2x plus 2, correct? So we'll call this as our equation 1, that as our equation 2, and this time we are going to substitute 1 in 2. Clear? So when I substitute this value of y, I get 3x plus 2 times minus 2x plus 2 equals to 5, right? So let's open the bracket. We get 3x minus 4x plus 4 equals to 5. 3x minus 4x, let's write 3x minus 4x equals to 5 minus 4. Or we have minus x equals to 1, x equals to minus 1, right? Now we know, let's call this as our equation number 3. So we'll sub 3 in first equation, which is to find the y value. So y is equals to minus 2 times minus 1 plus 2, that gives 2 plus 2, which is 4. And therefore, the solution here is the point x is minus 1 and y is 4. Clear? So that is how we'll get our answer. So if you substitute minus 1, you get minus 3. And here 4 times 2 is 8. 8 minus 3 is 5. It works. Perfect. Part G and H. Again, as we did last time, we need to isolate our variable, right? So you need to decide which one. So I think this is better to use, correct? So in this, we can write what y is. So y is equal to, taking other terms to the right side, we can write 2 minus 3x. Now in this case, x is a good option. So we can write x is equal to 20 minus 7y, correct? So that is how you have to choose one of the variables, whichever is simpler. So once you do that, you can say, well, let this be my equation number 1, this be my equation number 2. In this case, I'm calling that to be equation 1, this to be equation 2. And now we'll substitute 2 in 1. So the answer is sub 2 in 1, correct? And then rewrite. So first equation, 3x. Instead of y, I'm writing 2 minus 3x. Since this is plus, we can straight away write, right? Plus 2 minus 3x. We have minus 2. Sorry, equation number 1 is this one, right? 5x plus 2y minus 3y. So we get 5x plus 2 times y value is 2 minus 3x minus 3 equals to 0. So we get 5x plus 4 minus 6x minus 3 equals to 0. So 5x minus 6x is minus x, and 4 minus 3 is plus 1, correct? Equals to 0. Or we get x equals to 1. So once we get the value of x, let's call this as our equation 3. We'll sub 3 in 2, right? So we'll sub 3 in equation 2 to find the value of y, which is 2 minus 3 times 1, which is 2 minus 3 or minus 1. So our answer here is 1 minus 1. Is that clear? So if I substitute 1 minus 1, do I get 0? If I write 1 here, I get 3. Minus 1 minus 2 is minus 3. So you do get 0. So that helps. Is that clear? Let's do this question now. So we have x as 20 minus 7y. I'm going to substitute in the first equation. So which is 5 times 20 minus 7y minus 2y equals to 26, correct? Open the bracket. So we get 100 minus 35y minus 2y equals to 26. So on this side we have, so let's bring 26 here. So we get 100 minus 26 equals to, these numbers on the right side gives us 37y, right? So 100 minus 26, which gives us 4, and then 9 take away 2 is 7. 74 equals to 37, right? So y is equals to 74 divided by 37, which is 2 times. So y is 2. So let's substitute y equals to 2 in our equation 3, right? So we get x as equals to 20 minus 7 times 2, which is 20 minus 14 or 6. And therefore, our answer in this case will be 6, 2, correct? So I hope the steps are absolutely clear, right? So let's take up the next example, which is question number 3. You can always pause the video, answer this question, and then look into my suggestions. In question number 3, you can see that equations are slightly more complicated. So our first step will involve simplify equation. So the question reads, simplify each system and then solve it by substitution, correct? So we need to simplify them. So this set of equation I could now write as what? 3, 4 is in the denominator. We just multiply by 12. So we could write this as 4x plus 3y plus 12 equals to 0. The second equation for us will be 2x plus y plus 8 equals to 0, right? Since we need to apply strategy of substitution, let me just show this like this. We'll isolate y here, right? So let me rewrite this as 4x plus 3y equals to minus 12. Here we get y equals to minus 2x minus 8, correct? So we'll now substitute this value of y in equation 1. So I'm calling this as my equation 1, this is equation 2, and now we'll sub 2 in 1. Is that clear to you? So some additional steps are required when we have fractions and decimal numbers involved. Okay, so let's substitute this value of y. So we get 4x plus 3 times minus 2x minus 8 equals to minus 12. So we have 4x minus 6x minus 24 equals to minus 12. Take it to the right side, and here we get minus 2x equals to minus 12 plus 24. So x is equal to, that minus 12 plus 24, as you know, is 12 divided by minus 2, right? So we get minus 6 as the value of x. So once you get x as minus 6, let's rewrite here, x equals to minus 6. We know y should be equal to minus 2 times minus 6 minus 8, which is minus minus is plus 12 minus 8 or 4. So our answer here is what? Answer here is minus 6, 4. Is that clear to you? Right? So that is how we are going to solve it. Now let's do part B of this. Again, the first equation involves fractions. The second also involves fractions. So what we are going to do here is basically substitute the value of x into the second equation. We need to isolate also, right? So from this second equation, we can say x is equals to 4 plus y over 6, right? That is the value of x. So I'm substituting x over 5 as with this value. So let me call this as my equation 1 and this as equation 2. So when I substitute 2 in 1, what do I get? I have 1/5 of this x value, which is 4 plus y over 6 plus y over 3 minus 3 equals to 0. Now what I did here was that I did not simplify my first equation. Now it was a good practice to simplify, but I didn't, right? Then see how complicated it becomes, right? That's the whole idea. Okay. Now let's deal with it. So now what should we do? Well, once you are in this situation, we have no option than to work with bigger numbers, right? Okay. So let's multiply this. We get 4 over 5 plus y over 6 times 5 is 30 plus y over 3 minus 3. I can at least take this on the right side, correct? So we have on the left side, we can take 30 as common factor. We get y plus 10y, right? And on the right side, we get 3 minus 4 over 5, right? Since the space is lesser, we'll just kind of do this here itself. 5, we have 15 minus 4. So we get here y plus 10y is 11y, right? So 11y is equals to 30, will cross multiply, times 15 minus 4 is 11, right? So 11 over 5. Is that clear to you? So 11 and 11 cancel, and we get the value of y as equal to 30 divided by 5, which is 6. So slightly more complicated than what we wanted it to be. Now we can substitute this value of y in equation 2. So we get the value of x as 4 plus 6 over 6, which is 5, correct? So we have our answer, which is 5, 6. Is that clear to you? So we do get this answer. However, we adopted a method which was not very efficient. Therefore, if you have examples like this, it was a good practice to simplify and then move forward. Is that clear to you, right? If you don't, you will get the answer, but more calculations will be involved. So I hope that is a good learning. So let's move on and take the next question now. Number 4. For what values of coefficients a and b is 2 minus 1 the solution of the following linear system? Okay, so when I say 2 minus 1 is the solution, that means this point is common to both the equations, right? So that means this is common to both. So if I substitute 2 minus 1, so the point which is 2 minus 1 really means x equals to 2 and y equals to minus 1 on both these systems, right? So the two systems here we're talking about are, let's write down, 2 for x, so we get here 2a, y value is minus 1, so we get minus b equals to minus 7. And here if I write 2 for x, I get 4a, and minus 1 for y, I get plus 3b equals to 1. Is that clear? So what I've done here is that for these equations, I've used my point 2 minus 1. And now I've got two equations and two variables which I can solve for. So let us isolate b from here. So we can write b as equal to 2a plus 7. So I'm calling this as my equation 2, this as my equation 1. We'll now sub 2 in 1, right? Same step. So when I substitute b, 2a plus 7 in 1, what do I get? I get 4a plus 3 times 2a plus 7 equals to 1. So we get 4a plus 3 times 2 is 6a plus 21 equals to 1. 10a equals to 1 minus 21, which is minus 20. A is minus 20 over 10, which is minus 2. So we'll call this as our equation number 3. So we have a equals to minus 2, and we have b as equal to 2 times a, which is minus 2 plus 7, which is minus 4 plus 7, or 3. So we have our solution here, and that is a is equals to minus 2 and b equals to 3. Is that clear to you? So that is how we are going to solve this particular question. A very interesting question. It's a communication question seen in test papers. The last question here is kind of difficult. We need to now solve a system which is 1 over x plus 3 over y equals to 3 over 4, and 1 over x minus 2 over y equals to 5 over 4. I will actually like you to pause the video, answer, and then look into my suggestions. The last question, let us see how to solve this linear system. The strategy here is very important to understand. So strategy is we do a substitution right in the beginning. We will substitute 1 over x as equal to a and 1 over y as equals to b and rewrite our equations. Is that clear to you, right? So that is the substitution which we have made. So if I do that substitution, 1 over x is a, so I get the first equation as a plus 1 over y is b, so it is 3b equals to 3 over 4, right? The second equation is a minus 2b equals to 5 over 4. Is that clear to you, right? Now we could isolate. Now this equation could be solved very easy using method of elimination. However, we have to solve it using substitution. Okay, so what we will do here is we can isolate a from any one. So we can say, well, let a be equals to 5 over 4 plus 2b, right? So we'll substitute this value. Let's call this as our equation number 3, and that is our equation number 1. So we'll substitute 3 in 1. So we'll do sub 3 in 1, correct? So when I do that, I get, instead of this a, I'm writing 5 over 4 plus 2b. So we get 5 over 4 plus 2b, and we already have plus 3b here, equals to 3 over 4. So we have 5b equals to 3 over 4 minus 5 over 4, right? So we have 5b equals to minus 2 over 4, which is minus half, or b is equal to minus 1 over 10, correct? So we get the value of b. Now a can be found by substituting this value. Let's call this equation 4. Substituting 4 in 3, we get a as 5 over 4 plus 2 times minus 1 over 10, right? So that is 5 over 4 minus 1 over 5, correct? 2 times this is 1 over 5. Now, so there we get common denominator of 20, cross multiply 25 minus 4. So we get 21 over 20, right? So that is the value of a. Now what we started off with, that 1 over x is a, right? So what is x equals to? So x is 1 over a and y is 1 over b, correct? So we have our solution, which is the value of x and y is what? So 1 over a is x, which is 20 over 21, and 1 over y is b, which is minus 10, right? So that is how we get our solutions. So I hope the steps are absolutely clear. Feel free to write a comment, share your views, and I hope that gives you a fairly good idea about solving linear systems using substitution. As you have seen, many of these questions could be done using the method of elimination also. So that will be our next unit, where we will solve linear systems using the method of elimination. I hope you understand and appreciate it. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.